Hi guys, Lever here from Bright Young Brains. So in this video, obviously we are going through a full paper. This is the Gauteng Maths grade 12 prelim exam from 2022. This is the paper one, and obviously the PDF file is linked in the description. If you have any questions, you can always just hit me up on IG. And without wasting anyone's time, let me just get into this. So with the question like this one, right? The first thing that you want to keep in mind is if you're going to solve for x, fortunately, if your expression is equal to 0, what you know is you can make the first portion equal to 0, and then you can make the second portion also equal to 0. So from here, you know that you can divide both sides by 2, and then you have here x is equal to 0. For this one, the 1 can go to the other side, it becomes a plus. And then obviously anything that you put under a square root, you have to put plus or minus as your final answer. There we go. So the funny thing with questions like this is that, I mean, like, what's the mark location? It's a 2-mark question, so there's nothing to overthink really. Moving on, this obviously is what we need to look out for us to know that we automatically may need to think of the quadratic formula. So when I think of the quadratic formula, what we already know is that the quadratic formula says x is equal to minus b plus minus b squared minus 4ac. So the big idea, 4ac over 2a. So the thing is, this question, the way our question is laid out, we have to think outside the box, because this is actually a scenario where if you want to almost write this in a way that you don't have any fractions, what you could do is you could end up with like x plus, let's say here 2 with x to the power of 1, negative 1, and then minus 6 equal to 0. So the thing is, with a question like this one, right, if you want to write it in a format that is quadratic, remember a format that's quadratic has something like an squared plus bn plus c. This is a format that's quadratic. So in our case, what we can actually do is, what we know is that this is to the power of 1. So if you want to write this with something that is quadratic, that has something squared, if you're going to be creative, you can think to yourself, okay, fine, what to the power of 2, or rather 2 times, I mean, what times, what can I say? What's the easiest way to put this? You need to think of a number, right, that if you multiply it by 2, it's going to give you a 1. I'll repeat. In a situation like this, you want to think of a number such that if you multiply it by 2, it's going to give you a 1. You see, so the only number that you will multiply by 2 to give you a 1 is a half. So once you know that, you can write this as x to the power of a half, and then you just put it to the power of 2, because a half times 2 is what's going to give you this 1. Now the idea is, the moment you put this to the power of a half, you also then want to think to yourself, in this situation here, you see, one way or the other, you may be thinking to yourself, okay, fine, if we have x to the power of a half here, we may want to also have x to the power of a half over here, right? But then the only way we would get a negative 1 here is if you would be thinking to yourself, what number, right, multiplied by 1, right, can give you a negative 1, and which number multiplied by 1 can give you a negative 1? Nothing. So wanting to write this in a format like this for you to then use the quadratic formula doesn't seem like it's working. Okay, so what we can then just do is we can actually just leave this fraction the way it is over here. We can take everything to the other side. We're gonna have negative x minus 6. Now obviously we don't like working with fractions, so we can multiply this by x, multiply this by x, and then the x will cancel out. This is going to give us 2 is equal to x with negative x here minus 6. And then this is almost like, you could have also said you can get an LCD. So let's see, we have here, if you multiply inside, you have negative x squared minus 6x. Then these two can come over. You have a 0 here. So here, solving for x, you can clearly see we can use our quadratic formula now. Because using our quadratic formula, we have x is equal to minus b. B is like negative 6 plus minus, it's like negative 6 squared minus 4. Our a value is like negative 1. Our c value is like negative 2. The whole thing over 2a. A is like negative 1. And then, what do we have now? This we can just put in our formula sheet, or we can put that in our calculator, I mean. So putting all this into our calculator, we're getting two answers. The first one, x is equal to 0.35. The other one, x is equal to 5.65. Okay, so seems okay. Let us keep it moving. So the next question here, it's a question that clearly requires us to know our knowledge of inequalities. So when you work with inequalities like this, you need to be careful. So there are two ways to go about this question. Or rather, let's use the easiest way. The easiest way is to just do the following. Or rather, let me show the more universal way of working out this question. Or rather, let's not even think of universal. Let's just work it out. So what you can do is you can just multiply out these brackets first and then take the 6 over. So what that's going to look like is x times x, right, is x squared. X times the 4 is 4x. And then negative 1 times x is like negative x. Negative 1 times 4 is like negative 4. And then the 6 goes over, that's going to be like negative 6. This is equal to 0. And then what you already know is that there's x squared here. 4 minus 1 is like what? 3, right? Negative 4 minus 6 is like negative 10. And then now this is a question we can answer nicely, because all you want to do now is you want to recognize what kind of a parabola is this one. It's a smiling parabola. So since it's a smiling parabola, what you want to do is, this is asking you, where is this parabola above or equal to 0? So at these spots here, it's equal to 0. And then where it is above 0 is here. This is the part where it's above 0. And this part where it's above 0, right, it is where you start from this x value going to the right, start from this x value going to the left. So keeping that in mind, you need to keep in mind that moving forward, right, 10, you need to work out what this is, and you need to work out what this is. So factors of 10 that give you a 3, it's just 5 and 2. So there's like 5 here and 2. There's like x here and x here. To get a plus 3, you have to say plus 5 minus 2. And then this is bigger or equal to, well, whichever way, you want to just solve for x first in this case, you know? So solving for x, you're going to get x is equal to negative 5 or x is equal to 2. So here you're going to get negative 5, here you're going to get 2. So with that being said, right, you're going to say your x values need to be smaller or equal to negative 5, or those x values need to be bigger or equal to positive 2. So with that being said, you know that you'll be fine. You know, you would have said everything you need to say properly. You can just keep it moving. So in the name of keeping it moving, here we are. It's a 5-mark question. And already the one thing that stands out in this 5-mark question is how this bracket here is identical to this bracket over there. When you spot something like that, don't take it for granted, because asking this question is asking you to solve for x. So these are both under square roots and they look funky, you know, they just look like they're the thing in the question that's making this question not very straightforward. And that's why it's also a 5-mark question. So when you automatically and immediately spot something like that, we are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions. I'll be able to see them directly. We'll be able to chat. We'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. You need to make it into one variable. So you can say here, let k equal to square root of x minus 2. So this is going to give you k plus 3 over k. And then here you just have to solve for k. You can see the way this is structured, it looks exactly or very similar to this kind of equation. So we at least know what we can do. So here we can just get rid of the k, right? So to get rid of the k, we know we can multiply by k here, multiply by k here. And then here, I'm going to get k cancels k here. This is like 10. K times k is like k squared. 3 times k is like 3k. And then quadratic equation, right? So in this quadratic equation here, we know that solving for k is something we can actually just do. It looks a lot like like what we were just solving algebraically here. You see there's a plus 3 there, and then a minus 10. So I mean, this is just a coincidence in this case. K, we have here k over here. Factors of 10, it's like 5 and 2 that give us a 3. Plus 5 minus 2 here. K is equal to minus 5, or k is equal to 2. So the minus 5 may not give us some. Now let's see what we can do. Now here we can say, because we know what k is square root of x minus 2, right? So this is equal to negative 5. To solve for kx here, we can just square this side and square this side. This is going to give us a positive 25. This cancels that x minus 2. The 2 goes to the other side, it becomes a positive 27. For this one, square root of x minus 2 equal to 2. If you square both sides, you're going to have the square, it's equal to 4, it's equal to x minus 2. And then here x is equal to 6. So, I mean, in this situation, you can see that things are just looking up good. So you just keep moving forward, you know. The only thing is, in situations like these, you want to test out your answers, because normally when you have stuff that are under square roots like this, not both answers work. So let's test out the 27. 27, you would have 27 minus 2, which is 25. Square root of 25 is 5. 10 over 5 is 2. Here, if you put as 27, 27 minus 2 is 25. Square root of 25 is 5. 5 plus 3 is 8, not 2. So the 27 doesn't balance out the equation. In a situation like that, just maybe means the 6 is the only one that balances the equation, which is normally the case, because if you put 6 here and you put 6 there, it's the only one that will balance your equation. Let's move on. 1.2 simultaneous equations, as always expected. The 4-mark question. So, the way it's looking, Yeah, let's just isolate x. 1 plus 2y. Now here we're going to throw this into this equation. You see? So wherever x is, we're going to throw in the 1 plus 2y. So here, 2. And then we have, let me just actually write it from the far left here. So writing it from the far left, let's see. Writing it from the far left, we have 1 plus 2y squared, right? Minus 1 plus 2y, and then a y here also. And then here, minus 5y minus 3y squared minus 2 equal to 0. So us knowing all this, we just need to be careful here. Just take things nice and slow. So here it's going to be a 2, right? 1 times 1 is 1. And then plus plus 4y squared. And then we're going to have here this negative and this y can be put together, right? So if you multiply inside, it's going to be like negative y and then negative 2y squared. And then the rest here, it's like negative 5y, negative 3y squared, negative 2 equal to 0. So we need to just be taking things nice and slow, right? Because we don't want to rush and make a mistake unnecessarily. So from here, let's see. Let's multiply inside this. It's going to be 2 plus 8y plus another plus 8y squared. So one thing I can definitely say about solving questions simultaneously is that one of the things that will throw you off is your signs. So if you see that you're getting answers that look funny, trust me, just go back right to the beginning of what you would have written out and just check if your signs are written out correctly. So here, like terms, we have 8 minus 5. That's like 3. It's like 3y squared. 8 minus 6, that's a 2. Positive 2, so it's 2y here equal to 0. So this is very promising, at least because we can take out a common factor. And then here, we can just make y equal to 0 or 3y plus 2 equal to 0, meaning that the 2 can go over, right? So this is like 3y equal to negative 2 here. If you divide both sides by 3, you're going to get here, what do we get? Y is equal to negative 2 over 3, like that. Whew. Okay, so this is all nice and dandy. So once you've gotten these two values of y, right? There's 0 here, there's this here. You can just throw that into your main equation here. You see, so keeping that in mind, let's see what we can do here. Paste. So with this in mind, right, it's going to be x is equal to 1 plus 2. Then this is, let's throw the 0 first. It means x is a 1. The other one, we have to throw in negative 3 over 2, right? So 1 plus 2 and negative 2 over 3. So with whatever answers you're going to put here, you need to check them also. Because if they don't, balance out your equations, then there's something wrong. So here 1 minus this is going to give us negative a third. Okay, so those are our answers. So the thing is, yeah, if they don't balance out the equations, then you have a problem. But then in this case, if you throw negative 2 over 3 here, and you throw 1 there. Wait, no, negative 2 over 3 here, right? Let's see if it gives us, whichever way, the two equations balance out if you throw in your sets of y values and your sets of x values. So these answers are okay. Because if you throw negative a third over here, right, and you throw negative 2 over 3 over there, the equation balances out. In this equation, you can also just put stuff in your calculator if you want to be like super 100% sure. But then, whichever way, let us move on to 1.3 here. 1.3 is out of 3, right? It says, given this equation, where x and y are integers. Remember, if x and y are integers, what it means is x and y are like complete numbers that are either negative or positive. It's like -1, -2, going on and on and on, and then 0, 1, 2, going on and on and on. You see complete values, but they can be either positive or negative. So in this case, if they're going to ask you to solve for x or determine the value of x and y, you want to keep things simple for yourself, in the sense that don't be too extravagant, you know. So just try and see the method to the madness, in the sense that fortunately the left side, the bases are the same, the right side, the bases are the same. Left side, there's a common factor which you can take out, and then on the right side there's also a common factor which you can take out. So you might as well start there, you see, because you're taking out a common factor. Remember, here your bases are the same, so this 2x to the power of 1, right, can be written as this 3y to the power of 2. We know that it can be written as this. So we said here there's 3 to the power of y and the 3 to the power of y. We took it out, so this is left. Here 2 to the power of x is a common factor, so we took it out, this is left. So that now we can see that this is just 2 plus 1, it's a 3. And then this is 3 to the power of y. 9 minus 1 is 8. Now, obviously, at this point in time, you'll be wondering, but where is this even going? So if you're going to think outside the box, the one thing we already know is that 8 can be written as 2 to the power of 3. So the reason I've done this is because there's a base of 2 there with the x or something. So if you want to now align these, the left side and the right side, to look alike, you could write the 3 first. The 3 is to the power of 1, right? And then you could write the 2 to the power of x afterwards, so that you can see, okay, technically speaking, one way or the other, the 3 here goes with the 3 there, the 1 here goes with the y over there, and then the 2 here goes with the 2 there, the x here goes with the 3 over there, you see. So that now you can just say, therefore, y is equal to 1, x is equal to 3. So these are the kinds of questions where you don't want to overthink it, you know. You don't want to think, oh, you're going to work it out algebraically or whatever. No, just be calm. It's a 3-mark question, so this is what you can do for these kinds of questions. Now, 1.4 says 6 marks. Okay, so it's a 6-mark question, so we don't want to think too crazy. We are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions. I'll be able to see them directly. We'll be able to chat. We'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. If you don't like nature of roots questions, and like this is a 6-mark question, if it kind of just throws you off a bit just by reading it, don't even attempt it, because you're better off just going through the rest of the question paper and then coming back, because this is 6 marks, which implies about 7 minutes of your time. So you don't want to just throw away 7 minutes trying to figure out a question that is not your cup of tea. So I suggest in exams, you only look at these questions like when you're done with everything. So it says here the equations, this and this, they're both quadratic. They have real and equal roots. So if it's a quadratic equation, clearly we can see this is a value of 1 and the a value of also 1. Fortunately, because they are both parabolas that are smiling, we know that if you have a smiling parabola, however the parabola looks, as long as it's smiling, if it has equal roots, what that means is your parabola touches the x-axis once. So both of these parabolas, they touch the x-axis once. That's what this is telling us, real equal roots, because a root is basically an x-intercept. So here we're saying it has one x-intercept, this also has one x-intercept. That's what it means when roots are equal, because what that means is when your equations are factorized, right, they would normally have, they would have two brackets that look identical. So keeping that in mind, they said here, so for the values of r and m, if r is bigger than 0 and m is also bigger than 0. So the idea behind them asking us to solve for r and m, you have to be creative. So being creative, and if you're thinking of roots and all that, what you want to remember is that your roots will always be, if you have the word roots, we always know you have to think of delta, which is like b squared minus 4ac. So for equal roots, you have to be working with where this expression is equal to 0. So this is where we can start. For the first equation, if you're going to put values into this equation, b is r, a is a 1, c is a m. So we know that this is one existing equation, right? For our given information, this is an equation that exists. Now what we also know is for the second equation, we know that if the roots are equal, it means that b squared minus 4ac is equal to a 0. So our b here is m, our a here is also 1, our c here is r. So what we know is this, we could actually work them out simultaneously. Here we can isolate, let's see, r squared minus 4m equal to 0. The 4m goes here. You can actually divide, let me actually isolate m in this case, because yeah, why not? So this is a quarter r squared, right? This is equal to m. Here, what is this now? This is equal to m squared minus 4r equal to 0. This is equal to like 4r m squared. Now the thing is, if we have said that m is this value, we can just take this whole thing and throw it in there. But how is that gonna come out? Yeah, let's just do it. Let's see. If you're gonna throw this in there, right, you're gonna have a, let's just say r squared over 4. I mean, like, you know, r squared over 4 squared equal to 4r. So yeah, let's just square. Let's just remember the square goes for the top and the bottom. This is going to be 2 times 2 is 4. 4 squared is a 16. Now we're solving for r, so you could actually just divide both sides by r. Divide both sides by r, technically this r goes away, and then here you have r to the power 4 with 16 here. R will be at the bottom since you're dividing by r. So if you're dividing and your bases are the same, you can minus the exponents, you see. So 4 minus 1 is 3. So you have here r to the power 3. The 16 is down there. To get rid of the 16, you can now multiply by 16 on both sides. This is going to give you 64 r to the power 3 here. And then now you can cube root both sides, you see. Cube root this, cube root this. So here, fortunately, I think the cube root of, I think 4 is the answer, because 4 times 4 is 16. 16 times 4, 64. So this is the answer, 4. R is a 4. If R is a 4, you can put 4 there. 4 squared is 16. And then here, 16 times a quarter. What is 16 times a quarter going to give you? 16 times a quarter is going to give you a 4. So M is a 4, R is a 4. It's purely a coincidence that they're both 4s. But then you can clearly see that the reason or the method to the madness behind us working this out, it's not something crazy. It's actually using basic information to just get 6 free marks. So let's move on to question number 2. Question number 2. So we know we're dealing with sequences and series now. So with sequences and series, right? The one thing you want to keep in mind is that, yeah, the questions would normally be straightforward, whether it's prelims or finals. It says here, given the quadratic sequence, you have a quadratic sequence. Determine an expression for the nth term. 3 marks. So 20. Let me write this nicely. 20, 12, 10, 14. So this is like standard procedure, I see. 14 minus 10 is like 4. 10 minus 12 is negative 2. This minus this is negative 8. And then your next line here, more or less the same. 4 minus, this is where you have to be careful. 4 minus negative 2 is a 6. Negative 6 minus negative 8 is a 6 as well, because a negative and a negative you plus. The very bottom here, you make it equal to 2a. This you make it equal to 3a plus b. This you make it equal to a plus b plus c. Because you see, if they're going to need you to get this equation, you have to get a, b, and c. To get a, b, and c, you start from the bottom. You see, 2a is equal to 6 is what you solve first. So 2a equal to 6, you have to solve that first. So obviously solving that first, you have to divide by 2 on both sides. A is going to be a 3. And then, after that, you can throw 3 where a is here. 3 times 3 plus b equal to negative 8. So this is 9 plus b. So here, 9 moves to the far left. It's like negative 8 minus 9. So this is like negative 16 minus 1. That's like negative 17. So there we are. So moving onwards, right? We are going to have a plus b plus c equal to 20. So a here is a 3. B is a negative 17. C is c. I mean, c is just c because we're working it out, right? Solving for c here, the 17 can go to the other. Okay, let's just do it like that. 17 goes and then the 3 also goes. So this is like 37 minus 3. That's like 34. That's your value of c. So all this, we can see it's okay. Nothing bad, nothing crazy. It's just pretty straightforward. So Tn is equal to 3n squared. B is a negative, so negative 17 plus 34. Okay, the next one. 3 marks. This says the first differences form an arithmetic sequence. Yes, they always do. Because if you look at the first differences, right, it's these numbers, negative 8, negative 2, and 4, going onwards. You can see they have a common difference, which is a 6. So this is referred to as the first differences. And yes, there'll always be an arithmetic sequence since they have a common difference. So they said here, these first differences form an arithmetic sequence determined between which successive terms in the quadratic sequence the first difference will be 148. So all they mean is, in this sequence here, negative 8, negative 2, and 4. In this specific sequence, they want us to find out in that sequence, right, where do we have 148? Because somewhere up here, right, you're going to have two values where this number minus this one is going to give you 148. That's what they mean by this part here when they are saying determine between which successive terms in the quadratic sequence the first difference is 148. So all we need to do is we need to find out where 148 is in this specific sequence. Once we find out where 148 is, what you may call, in the moment we find out where 148 is, right, in this sequence of first differences, it will be easy for us to trace it back to the original quadratic pattern. Because you see, look, this is in position number 1, right? It's between term 1 and 2. This is position number 2. It's between term 2 and 3. This is position number 4. This is position number 3, right? And it's between 3 and 4. So That's the logic we're going to use behind us finding out what position this is. We'll be able to say it's between this term and this term. So finding out where 48 is in this sequence, it's easy because it's an arithmetic sequence. So in this arithmetic sequence, what we already know is that the common difference is a 6. So what we want to find out is position of 148. So our actual term is 148. Our first term is -8. The position of it, we don't know, we're looking for it. And then our common difference is just a 6. So since our common difference here is just a 6, let's see what we can do. -8, the 6 we multiply inside, it's like 6n, right? -6. This is 148. Now -8 minus 6 is -14 plus 6n. Now, with that being said, if you move this to the far left, right, 148 plus 14 is, I think, going to give us, why am I thinking? I should just use the calculator. But the calculator sometimes is boring. But never do things like that. Never do things like saying the calculator is boring, because you'll find yourself in a heap of a mess. But in this situation, let's see. Let's see, where's the calculator? So this is 148 plus 14, right? Plus 14 here equal to 6n. So what you then need to do here is, let's see, this is going to give you 162 equal to 6n, right? It's 162 because look, 148 plus 14. This plus that is a 2, 12, right? And then 4 plus 1 is 5 plus 1 is 6. And 162, yeah. So in this situation, you're going to divide both sides by 6. Let's see in our calculator. This is going to give us 27. So what we know is, if 148 is in position 40, if this is in position 27, so if this is in position 27, it means that this is term number 27. It means this is term number 28, based on the logic that we spoke about in the beginning. So that's what we're going to say in our answer. We're going to say between term 28 and 27. See, between T28 and T27. That's our answer. So that's nothing crazy with this question. These kinds of questions, they're definitely there in the online course. Like, if you know any friends that are signed up for the online courses, like, ask them nicely if these are the kinds of questions that we go through in the online courses. They'll tell you definitely. So this question is very familiar if you have gone through the online courses properly. The next one says, for 5 marks, determine the smallest value. Determine the smallest value of what? Determine the smallest value of n for which Sn is bigger than 10,140 in an arithmetic sequence. Determine the smallest value of n for which Sn is bigger than this in the arithmetic sequence. So in the arithmetic sequence that we're talking about, which is the sequence of first differences, we know that Sn is equal to n over 2 times a, n minus 1d. So with that being said, we need to keep in mind the following. So let's see. They're saying which value of n will this with the sum of the first n terms be bigger than 10,140. So we don't want to overthink this question. So for you to find out how many terms you have to add up to get this number, or rather how many terms, it says what is the smallest value of n for which Sn is going to be bigger than this. So if you're going to work out where Sn is bigger than this, you might as well firstly work out where it is equal to that. That's where you can start, because you know that whatever value of n you get, anything above that is, whatever value of n you get, it's the first value of n. Any value after that value of n is 10,140, right? And then let's see what you get here. So n, what is our value of n in this case? N is, we're working at n. A is, our first term was -8. And then our n is what we're looking for. Our d is +6. So solving for n here, we have to be careful. N over 2, -16. 6 times n is like +6n. Then 6 times that is like -6. This is 1,000. I mean, this 10,140. So let's see here, 10,140. Now, all this, right, we have to, let's see, moving forward, we have n over 2. -16 minus 6 is like -24. And then 10,140 is what we have here. So with all this being done, right, let's multiply inside. So we're going to have here -24n over 2. Then we're going to have here 6n squared over 2. 10,140. And then what do we have here? This comes, this is like -12n. This is like 3 over 2 is like, I mean, 6 divided by 2 is 3. And then this is 10,140. And then this is like 3n squared minus 12n, and then minus 10,140. This is equal to 0. Let's keep moving forward, right? So let's see here. Moving forward, we're going to have here, we can just use the quadratic formula for this one. N is equal to minus b plus minus b squared, b squared, right? B squared minus 4 AC, the whole thing over 2a. So b here is -12. And then let me see here. Let's see, b is like -12 squared. For the a value is what? A value is a 3. C value is -10,140. And then the bottom is 2 times 3. And then what's next? All this, let's put it into the calculator and see what we can get, right? But something doesn't seem right here. Is this a 12? 24? No, this is supposed to be like 6. Let me see, 16, right, minus. Oh yeah, that's supposed to be -22. Uh-oh. Yeah, there's the mistake. This is supposed to be 22, meaning this is supposed to be 11. Yo, that was going to be a big problem, eh? That was going to be a big problem. So this is 11, 11, 11, 11. So in this situation, let's see what we are getting here. So in the calculator, n is going to be equal to 60, or, and in this case, this other one would be, the other one is a negative, so that's not applicable. So what that means is, where n is equal to 60, if you add 60 terms, they'll be equal, they'll add up to 10,140. So they said, what is the smallest value of n for which the sum of those certain number of terms will be bigger than this number? So if 60 terms gives you exactly this number, it means just 1 after 60 terms is like 61. So 61 terms is what you need to add up for you to at least get something bigger than this. So the value of n, the smallest value of n, where what you add up is bigger than this, is going to be 61. You see, because if you add up 61 terms, that's the only time when you will have the number of terms being more than 10,040. So here you can say, therefore, 61 terms have to be added for Sn to be bigger than 10,140. You see, so you can even say, therefore, 61. I know, just this should be fine. Let's not overcomplicate it. Let's not overcomplicate it. In this situation, you can even maybe try and adjust this and try and show that whatever end value you're gonna get, it needs to be bigger than 60. So let us move on. For 3 marks, they said, what did they say? If your expression here is equal to 10a, determine b in terms of a. So the logic behind this is, you have to remember that this is actually telling you that you have a sequence, right? But terms were added up. Terms were added up starting from this number, ending up at this number. And when those terms were being added up, right, this was your formula. That's what your structure for sigma notation means, you see, because you'll have a sigma symbol here. They'll tell you you're adding up terms starting from down here, ending up here, and this will be your formula. So keeping that in mind, right? Keeping that in mind, you need to think of the following. So the one thing that we need to keep in mind is we're adding up, how many terms are we adding up? 5 terms. So what you do is term number 1, you have to throw, starting from this number here, whatever this number is, you throw it in there. So it's going to be 1 plus b technically. And then the second term, it means you have to throw 2 in there, right? So you're going to have here 2 plus b. The third one, you're going to have there 3 plus b, right? Going on and on and on. By the fourth one, I mean, like, you can already guess, right? 4 plus b. The fifth one, 5 plus b. So the idea is, remember, because this is a sigma expression here, it means you have to add all these up. You're adding up everything. Now they said after you adding up everything, it is going to give you 10a. So this is equal to 10a. Now the idea is, they say determine b in terms of a. So we don't have to worry too much. We have to just think to ourselves, okay, fine. All these are being added up, right? So if you think of it nicely, it's like 1 plus 2 plus 3 plus 4 plus 5. It's like 9 plus 3 is like 12 plus 2 is like 14 plus 1 is like 15. So like 15, right? And then here it's like 1b, 2, 3, 4, 5 b's plus 5b. Let's go to 10a. So since they say we should determine b in terms of a, it means b should be our subject of the formula. So this is like 10a minus 15, right? And then what we now know is that you can just divide both sides by 5, right? Divide by 5, divide by 5. Then you're going to have here divide by 5, divide by 5. That's like b. Negative, 10a over 5 is like what? 2a. And then 15 over 5 is like what? 3. So this is what b is in terms of a. And we can see that was not too crazy. The next one, we can move on to question number 3. Question number 3 says the following. Given the following geometric sequence, right? So they told us it's geometric, so I guess that's already something blunt and straightforward to keep in mind. It's a geometric series, geometric sequence, as they said. You can see here, series, sequence, It's really not a big deal. So let's see here. They said calculate the what you may call, what should you calculate? You should calculate the what is this? The sum to infinity of the series. They said we should calculate the sum to infinity of the series. So if you're going to calculate the sum to infinity of the series, it's a 4-mark question. The one thing to just remember is that the sum to infinity, there's a formula, a 1 minus r. In this situation, fortunately, a is this term. Your value of r, it's always any term divided by the previous one. So fortunately, it looks as though we can use these two to get r. So r in our case is going to be equal to 6x over 12, right? 6x over 12. The easiest way, this is 6x over 12. This is just going to be a half x because 6 over 12 is a half. And the x is there. So here, calculating the sum to infinity, our a value is already a fraction, right? So we have a fraction. This line here, you see this line? Let me put it in red. It's a division line. So that division line, for the sake of making calculations, or for the sake of our calculations, we can just write it as a division symbol. You see this line here, we're writing it like this. And then here we have 1 minus r, right? So we have here 1 minus r. Let me actually just put it as x over 2. So the reason I've done this is because, firstly, to make our lives easy, this is just 1. Since this is a fraction, this is also a fraction, it's better if we maybe just put this as 1 over 1. The reason for that is, before you can say you flip and you multiply, what you want to do is make this one fraction. So meaning you have to get an LCD in there. The LCD is just going to be a 2. So you see here, times 2 over 2. Meaning you're going to have in that bracket here, you're going to have the 2 times 2 is a 2. The denominator is just a 2. So now that you have one fraction, you see, the reason why it's now one fraction is because it has the same denominator. So because it now at least has the same denominator, you can now flip it over and then multiply. So let's see here, this is 24 minus x. This changes to a multiplication symbol. So changing this to a multiplication symbol, you can just flip this over. There's a 2 on top. And then you have here 2 minus x. So that being said, let's see. At the top, you have 24 times 2, right, which is like 48. The bottom, you have x. This is together. So if you're going to multiply the x, it's going to be x times 2, which is like 2x, x times the negative x, which is negative x squared. So remember, this is what the sum to infinity is equal to. But the thing is, if they asked it like that, they may be expecting like an actual number, which is where things get a bit crazy, because you'll be thinking to yourself, it's a 4-mark question. But the thing is, I don't think they would be expecting an actual number here, because our expression does not have actual numbers anyways. So this is as best as you can leave it. You know, you don't worry too much about getting an actual value because your sequence does not have actual values anyways. So this should be good enough. Moving on. 3.2 says for 2 marks, write down the values of x for which this sequence converges. So any sequence, if you've gone through the online courses on our website, I mean, the link to that is in the description. If you have gone through the online courses on our website, the one thing you already know is that questions like these, all you need to do is for you to get the values of x or the values of anything for which your sequence converges, you just want to think of this expression. The reason is that any sequence that converges, it means the sequence is getting lower and lower and lower. So the value of r is between -1 and 1. So in our case, we know that our value of r is just a half x, remember, x over 2. So since we have our value of r, our value of r is just x over 2. So what you do is, if you're going to work out the values of x for which your sequence converges, whatever your value of r is, you throw it over there, and then you solve this inequality. Solving this inequality, remember, for you to get rid of the 2 down there, you have to multiply by a 2 everywhere. times by 2 here, times by 2 there, times by 2 there. This is like -2. And then this cancels that, right? So it's going to be like x. And then here, what you get now? 1 times 2 is 2. So with this being said, yeah, you can just move on actually, because there's really nothing. No. Wait, what? Yeah. There's really nothing much to do here. You can just move on. So moving on, let's see what we can say. So in this situation, this you can write out in the beginning, and then this, and then this. All three is good for you to write out. The next one says, for which values of x will the series increase? That's kind of crazy. That's kind of interesting. Funny enough, it's just the opposite. No, it's not necessarily the opposite. Remember, for a sequence to increase, right, it just means it's all about your common ratio. So if your numbers are going to be getting bigger and bigger and bigger and bigger and bigger, your value of r just needs to be a number that is bigger than 1. You see, logically speaking, because you need to be multiplying by something that is at least bigger than 1. So for your sequence to increase, r has to be bigger than 1. So since they're asking for the x values where that is happening, we can just throw r here. You see, r is x over 2. And then if for x here, you're going to see here, you're going to multiply by 2. So you multiplying by 2 on both sides, right? You're going to get here x is bigger than 2. Since x is bigger than 2, yeah, that's it. That's all you have to do actually. Let's move on. 3.4, what does it say? 3.4 says the following. If x is equal to 4, determine the sum of the sequence to 15 terms. So this is fine because this is a geometric sequence, you see, and it's a geometric sequence that converges. So you can use this format of your SN formula, because remember your SN formula, you can write it with these two swapped around, or yeah, you can write it with these two swapped around, because normally you also sometimes see it like this. So anytime you see that your value of r is like between -1 and 1, for the sake of calculating your question more easily, you can just swap these around. You see, that's 100% valid. So these are two formulas, they both work, but in our situation, we're going to use this pink one here. So the sum of the first 15 terms, right, where x is a 4. So let's see here, S15. What we know is a is this fraction here. So this is like 24 over 4. So what we already know is a is 24 over 4, which is just a 6. So this is a 6 here. And then r is x over 2. So since r is x over 2, this is going to be 4 over 2, which is a 2. So this is 2 to the power of n, right? And then r here is, we got it to be a 2, so this is a 2. So, oh yeah, n is a 15, so this is a 15. If you put everything into the calculator, let's see what it gives us. Okay, so let's see. Oh, no, this is not right. What? Yeah, this doesn't seem... But how come our value of r is a positive number now? Oh, if r is a 2, then it means it's not a sequence that's converging anymore. Oh, yeah. So this won't work technically, because if r is a 2, automatically the sequence is not converging. So that formula doesn't work. Not necessarily doesn't work, but it's not ideal to use, as you could see. So here this is a 6 for a, r is a 2, n is a 15, and then here 2 minus 1. Let's see what this gives us. Wait a minute. Yeah, that other question, that one also was going to work in the calculator. I don't even know what I'm doing. But no, I do know what I'm doing. Well, if you rewind, right, and you put that, what I wrote in the calculator, you'll see it will still give you this number in the calculator also. 196,602. Let's move on. Question number 4. Question number 4 looks good. I just literally said that, but I guess let's see. It says the graphs of f of x, right, and g of x. So it's two graphs. One is a parabola, one is a hyperbola. The two equations are left blank, which is quite mean of them. But I mean, the more blank they leave it, the more marks, I guess. Well, whichever way, the test is out of 150 all in all. So it is what it is. It doesn't matter. But let's see. These are drawn. They said here they are drawn in the sketch below and have the following properties. The question looks familiar. Well, not necessarily this exact one, but the structure and the nature of it. I promise you, if you do go through the online courses on our website, when you will be going through these exams, you will really see why these are actually quite powerful. The link to that is in the description. But anyway, so A is, where is A in the graph? You see, when you're going to be reading anything, always be referring to the sketch. So A is an x-intercept. Okay, fine. It's an x-intercept of the parabola. P is the turning point of the parabola. Yes, it is a turning point of the parabola and lies on the vertical asymptote. Okay, so let's just keep this in mind, that the x value of P is the same as 1. Fortunately, we can see it there. Then it says if the vertical asymptote passes through 1 coordinate 0, you see, this vertical asymptote passes through 1, so the x value of P is also a 1, you see, because they are aligned like that. Then they say the horizontal asymptote passes through 0 coordinate 2, so that's fine. Really? Horizontal asymptote, x value is a 0, y value is a 2. Oh yeah, of course. Yeah, because x value here is a 0, y is a 2. Then it says the graph of G passes through the origin. So if it passes through the origin, the graph of G automatically has this as a coordinate. Now, that's all the information we really need really for us to answer all they're going to ask, because whatever they can ask is because they've given us the information to work it out. They said show that the equation of G can be written like this. Well, that's not going to be too difficult because fortunately we have the one asymptote, we have the other one, and we have a coordinate that the line passes through. So a coordinate that the graph passes through, so it's all good. So x and then a, b, c, right? So here we can say y is equal to a, b, c. So I don't even know I'm rewriting this, but whichever way, because of our knowledge, what we know is that let's just give them an idea why we know this is -1 and why we know this is 2. What you can say is, well, whichever way, it's kind of awkward, this kind of a question, because it's almost like you just be copying what is being suggested. But because of the knowledge they've given you, what you can say for yourself is you can just show that you know what you're doing by working out a value of a, because it's a 3-mark question anyways. So what you do is you make y as 0, because you're going to throw in a coordinate that you know, right? So y is a 0, a is what you're looking for, x is also a 0, and then this is the x asymptote, right? It's a +1 here, so it's going to be a -1 on the equation. If it's a +2 for the y, it's a +2 on the equation also. And then let's move everything. Let's move this to the left, right? It's going to be -2 a over -1. So this is like what? Times -1 times -1. Then you're going to get it here. A, this is like -2 times -1. That's like what? 2. And then what do you now know? Yeah, so you can then say therefore y is equal to, then you give whatever you need to give here, literally, because the other stuff is just given in the graph. Let's move on. 4.2, calculate the coordinates of P. P is just the turning point. So let's just check the mark allocation actually. It's a 3-mark question. So it's a 3-mark question. Well, yeah, you may be thinking how you're going to get the x value there, or the y value rather. Well, getting the y value over there, yeah, it seems like you may just have to get the equation of the graph, because yeah, it seems like we have no choice, because no, we don't have to get the we do. Fortunately, no, we have the equation of the graph. We have more than enough information to get p, because we have q already. Q is just, I mean, we have p, which is just the -1. So getting q is what we're being asked. Right? We're getting coordinates of p. Oh, the confusion here is the coordinate name is p, but I'm referring to this. You see, or rather, I'm just referring to this. How what we know is, you see this here, and this represents the turning point. So in our equation of our parabola, what we know is, you see, there's already a 1 given in front, because this format here is in the format y is equal to a x minus p squared plus q, right? So in a situation like this one, what we know is the fact that a is given, it's just the 1. So we can throw in a coordinate that the graph passes through. We can throw in our value of what you call p here, and then we can get q, because as long as we get q, we at least get the full coordinate of p. So let's do that. So our y value that our graph passes through, we can use this point here. The y value is 0, x value is 5/2. So the equation of our graph, right, they gave it to us like this. F of x is equal to x plus p squared plus q. Now the equation, we know that the y value is 0, and then x value is 5/2, and then the x value of the turning point is a 1, right? So in the equation, you need to put a -1. And then q here is going to give us the y value of the turning point. So there's an invisible 1 there, which is fine. So this -1 is like 3/2. 3/2 squared is like 9/4. And then moving the 9/4 over, it's going to be -9/4. This is what q is. So since we know that's what q is, it's the x value of, it's the y value of the turning point. So it means that p, the x value, we already know it's a +1. Yeah, it's a +1 in the equation. So the y value here is like -9/4. Let me remove this here, because like it's making it look a bit tacky. Anyways, let's move on. So this is like 4.3. 4.3 for 1 mark says, write down the equation of the vertical asymptote. Which vertical asymptote now? Vertical asymptote of p if p is equal to this. So this is just saying the graph of g has been moved horizontally. This has been moved horizontally. Yeah, it has been moved horizontally. Right, it has been moved. Come on, bro, come on. Remove this thing. It has been moved horizontally. It has been moved horizontally, and specifically to the right, 1 unit. So if the graph moves 1 unit to the right, the vertical asymptote is the x asymptote, if I can put it that way. The one that cuts the x-axis. So if the whole graph moves 1 unit to the right, then obviously instead of cutting at +1, it's going to cut at +2. So the equation would be x is equal to 2, because any equation of a dotted line going downwards like that, it's going to be x is equal to whatever x value it cuts. So we don't have to worry too much about that question. It's quite straightforward. 4.4 says determine the equation of the axis of symmetry of G in the form like this. In this format, if your m is smaller than 0. So again, these kinds of questions, if you have gone through the online courses on our website, right, of which the link is in the description, if you've really been going through these courses, or if you do go through these and you have not like reached the functions and graphs online course, what you need to keep in mind is these are the kinds of things you're going to be learning in there, so that you just see that these questions are straightforward. All they're trying to say is, remember, you have a graph of G. Your graph of G is a what you may call, it's a hyperbola. You see, so with your hyperbolas, you have to remember that your hyperbolas have axes of symmetries, two of them. There'll be one like this one, there'll be another one like that. This one will always have a negative gradient, the other one will always have a positive gradient, like always and forever. The positive gradient will always be a positive one, the negative gradient will always be negative one. So the thing is, with that knowledge, right, they're asking us to get the equation of the axis of symmetry, the one that has a gradient that is smaller than 0. So obviously, if they're talking about a gradient that is smaller than 0, they are obviously talking about the one where the gradient is -1. So already what you know is, in whatever equation they'll ever ask you about an axis of symmetry, the one thing that's already always given is which one they want, the positive one or the negative one. So if they want the negative one, already you know that your equation is going to be y is equal to negative x plus c. You just need to get a y-intercept. So the easiest way to get a y-intercept is to remember that you can use this format to get the equation of a straight line. So this format, it allows you to get the value of c if you just throw in a coordinate that the graph passes through. Well, you can actually just do it here also. You can just throw in a coordinate that the graph passes through and then you work out c, or you can just do it in this format, whatever floats your boat. But I think for the sake of what we have just done so far, might as well just work out c here by throwing in a coordinate that the graph passes through. So any axis of symmetry, the one thing you also want to remember is that your axis of symmetry will always pass the point where your asymptotes meet. So here x values are 1, y values are 2. So because we know that that's a coordinate, right, we can get c here. To get c, you're going to have here, what are you going to have here to get c? What is the x value? How? X value is a what? Is a 1. C value is a, what's our C value? C value is a 2. No, X value was a 2, yeah. And then here, the -1 goes to the other side, right? So it's going to be 3 plus 1. I mean, 2 plus 1, which is a 3. And then what? How? Yeah, C is equal to 3. So what is next now? What do I mean by what is next? How? I mean exactly that. Wait, yeah, we got C, so you can say therefore y is equal to negative x plus 3. Whew, okay. This is for 2 marks, right? 4.5. What does 4.5 say? 4.5 is an interesting question because, yeah, it really just is interesting. But I'm busy asking myself, why is 4.5 interesting? Because anything to do with K stuff, K this, yeah, it's always like, okay. Anyways, let's see what this wants us to do. Write down the equation of K if K is the reflection of G about the x-axis. So anything reflected about the x-axis, what happens is your y values is what changes, you see. So the graph of G, the equation of the graph of G, remember it's like 2x minus 1 plus, was it plus 2? Yeah, I think it was plus 2. So because we know this is the original equation, right? The idea is, if it's reflected about the x-axis, we are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions. I'll be able to see them directly. We'll be able to chat. We'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. It's the y values that get affected. You see, positive y values become negative, and the negative y values become positive. So because this is saying g is equal to this equation, remember, it basically also reads like y is equal to something. So a reflection about the x-axis just flips around the y values. So if a graph is going to be reflected about the x-axis, right, what you do is the whole equation you multiply it by a negative, because it's you changing the y values from positive to negative. So what you do is, in this case, I mean, like our graph of k, it's just going to be equal to negative g of x. So if it's going to be equal to negative g of x, it means it's going to be equal to negative 2 over x minus 1 plus 2. This is where you have to be careful now, because when you'll be multiplying your negative inside, you're going to just work with the top. You see, it's going to give you negative 2 x minus 1 and then minus 2, because that's how you multiply a fraction with any value. You just target the top if what you're multiplying by is not a fraction. Remember, here you can imagine it's just technically a minus 1 there, you see. So let's see, this is k of x. Just put that there. Let's put this here. Anyways, again, if you need more clarity, I promise you the online courses on our website is the best thing that you can do for yourself, like proper. Anyways, moving forward, right, to question number 4.6. 4.6 is obviously quite interesting because, well, it's just a 2-mark question. It's just a 2-mark question. It just says, for which values of x is this equation bigger than 0? Where is this equation bigger than 0? So if we're going to work out where this equation is bigger than 0, this is where you have to know your knowledge well, because this is not the kind of a question that you just guess what to do. You either know exactly what to do, or you just don't, and you just leave it and you move on. But as mentioned, if you do go through the online courses on our website, then these are the kinds of questions that you'll obviously be able to work out. Now, also in like the workshop that we are hosting on the 18th of October and on the 19th of October, these are the kinds of questions we're also going to be tackling here and there, depending on what is asked. So if you're wondering what I'm referring to, I am referring to the workshop, the live workshop that we are hosting, on the 28th and the 29th in Bryanston, which is the Joburg branch, and then on the 20th and on the 21st, that's the Pretoria branch. So obviously, if you go on our website, right, you'll see that there's one of two workshops you can sign up for. There's the Bryanston workshop. It's an in-person workshop. The $399, there are 2 ways to attend, you see. The first way to attend is in person. That's going to be $999. And then the second option is if you want to attend online, that's $399. The location is 22 on Sloan, Bryanston. The date 19th and the 20th from 8:30 to like 3:30. So for you to attend in person, it's obviously going to be the it's obviously going to be the 999 over here. You see, so you can either attend in Bryanston or you can attend the one in Pretoria North. So the one in Pretoria North, obviously, same idea. First option is the in-person option. That's going to be $999. The second option is if I want to attend online, but then you attending online, that's just going to be on the 18th and the 19th. That's the one that's going to be online also. But then in person, you have the Bryanston option, which is on the 18th and 19th, or the Pretoria North option, which is on the 20th and the 21st, as you can see here. So yeah, if you want to attend in person, it's going to be 999. The banking details are over here, or you can purchase directly on the website. So if you're going to attend in person, you can just click on purchase here, and then you'll be able to make your purchase on the website to like book your spot. But anyways, let's see this question. It says, for which values of x is this equation bigger than 0? So this equation is bigger than 0. You have to remember, firstly, before we worry too much about what this is and what this is. Remember, this is just saying you're multiplying two things together. And they're asking where will those two things together be multiplied together and you getting a 0. Like what needs to, you just need to think to yourself, something times something. The only way it can be bigger than 0 is if this is a plus while this is a minus, or this has to be a minus while this is a plus. These are the only two scenarios where no, the other way around. Bro, come on now. If you're gonna multiply two things together and the answer is gonna come out as a number that is bigger than 0, that can only happen if you're multiplying a plus and a plus, or if you're multiplying a minus and a minus. See, those are the only situations. So the idea now is you have to think to yourself, okay, fine, what do these symbols even mean? You see, so this first symbol means, this second symbol means the graph of g, the y values of g. So that's what we need to keep in mind. One of them is referring to the y values of g. The other one is referring to the gradient of f in different places. So the thing is, before you can answer these questions, let's just go through it, right? So in terms of f is our parabola. Our parabola, if you're going to think of the gradients of our parabola, what you need to remember is that going downwards here all the way until the turning point, you have to remember that all these gradients here, they are negative gradients. See, this is all the parts where your gradients are negative. You see, because this is saying the first derivative of f. The first derivative of f refers to gradient. You see? So this is where we have negative gradients. And then after that, we have this. This is where you have positive gradients. You see? Now, if you look at our hyperbola, let's look at our hyperbola. Our hyperbola, that's what g is talking about. G is talking about the y values of g. So y values of g, let's just say this is where the y values of g, right, are positive. And well, let's color code it, right? So if we're going to talk about where the y values of g are positive, let's use red. This is where the y values of g are positive, right? And then this part here is also where the y values of g are also positive. You see. So apart from that though, this is where the y values of g are negative. We are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop, on the 18th and the 19th of October, you will also be able to follow the brainstorm proceedings online via Zoom, meaning you'll be able to ask questions. I'll be able to see them directly. We'll be able to chat. We'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. So with us knowing all that, right, let us do the following. Let's now look for cases where they are both positives and where they are both negatives. So clearly they are both positives from where x is a positive 1 going to infinity, because that's the section where they are both red anyway. So what we know is, to answer this question, the first portion of answer that's valid is where x is bigger than 1, because from this x value of 1, right, everything towards the right, you can see it's red for positive y values, red for positive gradients, so that works out. And then the portion where they are both negative at the same time simultaneously, it's between 0 and 1. You see, between 0 and 1, you can see that we have negative y values and negative gradients also. So we can say here, oh, x has to be bigger than 0, right? What you may call, or x is smaller than 1. Yeah. So yeah, between 0 and 1. So with this being done, you could have just said x. Yeah. So here, this is important that you put your answer like this. If you had said x is bigger than 0, but then x is not equal to 0, that's also fine. I mean, if you had said x is bigger than 0, but then x is not equal to positive 1, that would also be fine. So that's that for this question. Let's move on to the next part of it. So moving on, let's see. 4.7 says, for which values of k will this equation have two real roots of opposite signs? So again, if you have properly gone through the functions and graphs course, these questions actually make sense. So G is our hyperbola. K is something that moves the graph up or down. It's a vertical shift. So since we know that K is a vertical shift, right, they're asking you how many units up or down do you need to move your graph for it to have two roots that are of opposite signs? Meaning, how many units do you need to move K, right, for it to have one x-intercept that's a plus and then one x-intercept that's a minus? So the idea is, if you move your graph at least, if you move it like at least 2 units downwards, if you see here your x-intercept is your y asymptote is originally at 2. So what that means is, if you at least move your graph only 2 units, your hyperbola would look something like this. You'd have your Cartesian plane here. Your x asymptote, we know that it would stay exactly the same, but x asymptote is still at 1 here, right? So if you have moved it exactly 2 units downwards, your graph would visually look like this. You see, you'd have your curve over here, you'd have your curve over there. It wouldn't have any x-intercepts because the asymptote would be here at 0. This is if it was just moved 2 units. Let's say moved 2 down. But then the moment you move it at least more than 2 units downwards, then you have a new image. Now, anything that has, the moment you move this more than 2 units downwards, your asymptote here will be anywhere somewhere there. Your original asymptote is still wherever it is. And then you would have here curve over there, curve over there, right? So you can see that one way or the other, this here, you have one x-intercept. this x-intercept is a positive number, whereas initially it was having an x-intercept that's like a negative. But let's see the question. For each value of k, will this equation have two roots that are of opposite signs? Yeah, so this question is kind of shady. The reason why it's really kind of shady is because, I mean, like, for a hyperbola, two roots, hi man, opposite signs, nah fam, this don't make no sense. The reason why I say these don't make no sense is because, yeah, it just doesn't want to make any sense, you know. The reason why it just doesn't want to make any sense is because, I mean, with the hyperbola, a hyperbola cannot necessarily have two x-intercepts. I don't even know why I was concentrating too much on what I just said right now. Well, it is important that I concentrated too much on what I have just been saying, but what's important is the fact that a hyperbola cannot have two roots. So there's something wrong with this question. I think they meant G. So this, I would put a question mark. And yeah, logically speaking, G cannot have two roots. So there's something wrong with the question for this one. G of x cannot have two roots. There's an error with this question. Error. So the thing is, if they had been talking about f, that makes sense, because my suspicion is that this x-intercept here is probably like a 2, I mean a -2. That's my suspicion. Let's see here. Y value, if you put y as a 2 here, let's see if you get a 0. I'm just gonna test my logic here. If you put y as 0 somewhere, yeah, let's see if you put y here as -2. What is the x value? I just want to test out something. See, because if I put y as -2, right? Let's see if we get a 0. So it's 1 here, x minus 1 squared, and then this is like -9/4, right? This is like what? This goes over, so it's like -2 plus 9/4. -2 plus 9/4. Yo? Yeah, ne? And then if you square both, why am I even? We have to see if x is a 0. No, we just have to see if x is a 0 here. Let's just see if the equation balances out. If x is a 0 here, we're gonna have, yeah, it doesn't balance out. Yo, whichever way, yeah, I'm just gonna, yeah, this question don't make no sense. Well, maybe it's just me. For which values of k will this equation have two real roots of opposite signs? Yo, graph of g, real roots, 2 of them. Yeah, these don't want to make no sense. Yeah, so this one, that's my suggestion for now. But let's move on to question number 5. Question number 5. So let's see. Question number 5 looks quite interesting, right? So thinking of what we've been asked here, so let's see, it says the graph of g. This is an exponential graph, clearly, where a is a positive number as sketched below. P, they've given us a coordinate of p. Then they said here p is a point on h. 1 mark, write down the coordinates of q. So writing down the coordinates of q, what is, well, I'm hoping q is the x-intercept. I mean the y-intercept rather, because it's like, yeah, that's the only logical thing, because if they're talking about this point, they normally label it O, because that would be the origin, you see. So if you're gonna get q, you don't even have to worry about having a, because getting q, you just make your x value as 0. So if you're gonna make your x value as 0, anything to the power of 0 is a 1, you see. So that's how you know that, okay, it doesn't matter if you don't have a. So here q, x value is 0, y value is a 1. So now they say determine the value of a. So getting the value of a is really quite straightforward, because I mean, like, you have a coordinate that the graph passes through anyway. So -1, and then here you have a half, right? So y is like a half, so you're gonna have a half here, and then x is like what is x? X is a -1, so a to the power of -1 over there, a to the power of -1. So what you can actually do is, in the calculator, you get the liberty of doing something like this. Your calculator will give you an answer, fortunately. So here, this cancels that, you're gonna get a, and then here your answer is gonna be a 2. Moving on, for 2 marks here, they say write down the equation of the inverse. That's what this is, inverse. So writing down the inverse, I mean, like already you know that the equation that they gave you, right? It's in the form f of x is equal to, h of x is equal to something, something, something. So you're gonna write it with I mean, like, firstly, h of x is equal to technically 2 to the power of x, since you got a now. So what you know is here x becomes y becomes x. That's what the inverse is. Remember, this represents y, right? So you're going to make it equal to x. This represents x, so you're going to make that equal to y. Solving for y, you can just use logs, because logs, basically, you use them if you're trying to isolate an exponent. Like here, you're trying to isolate y, right? It's going to be equal to log. The base is a 2, and then whatever this number is, you're just going to put that over there. So with that being said, right, let's see. 5.4 says the following: sketch the graph of the inverse on your answer book. Clearly show intercept with the axis. Well, sketching the inverse is quite straightforward and simple. That's why it's just a 2-mark question, because as long as you have your line of inverse, you are good to go. Because firstly, if you draw the original one, it'll make your life easier. You see, because the original one looks something like, something like this. This is what the original one looks like. You see, the original one looks like this, but they want us to draw the inverse. So the reason why I drew the original is so that you can see what you do to draw the inverse. The inverse, all you do is, you look to yourself and you say, this arrow here, you see you have to trace it towards the line of inverse. So whatever this distance is going towards the line of inverse, it should be the same distance that way. You see, so your arrow will be somewhere there. At the top here, you see your arrow there, the distance towards your line of inverse is the same the other way. So your arrow should be somewhere there. And then your curve, it looks something like that. You see, draw your arrow there. So your inverse is like this, because these have to be mirror images of each other, these graphs here. So the original one, we don't need it. We just used it to get an idea of what the inverse will look like. And that's something you can always do for yourself. You can always just draw your original in pencil, and then you can use this dotted line to guide you. Next question, 5.5. Write down the domain of the inverse. Well, I mean, we're looking at the inverse visually now. I mean, if the original graph, already we can see the asymptote is y is equal to 0. That's the asymptote. So the graph does not touch y is equal to 0, the original one. The inverse, we know it does not touch where x is a 0. So the domain, we can see it's just x values that are bigger than 0. You see, x has to be bigger than 0. Hence, or otherwise, determine the values of x for which this is bigger than 1. So this is where this is the inverse, right? They're asking you where is the inverse bigger than 1, I mean. So working out where the inverse is bigger than 1, I mean, like, the easiest thing you can do is to work out where it's equal to 1 first, you see. Because the moment you know where it's equal to 1, you'll be able to trace to see where it's above 1. So this is literally asking you where the y values above 1, So you can say the y values are above 1, starting from a specific x value until a specific x value. So we said, first, let's just work out where this graph is equal to 1 in the first place. So log 2x, where is it equal to 1? Now, solving for x, remember, all we know is whatever this base is, right? You can always think of it as a base also when you reshuffle what you need to reshuffle. So remember, normally when we use logs, we always say whatever is alone, we think of that as like, you know, the exponent at some point, and then this would be the base. So reversing that, you'd have here a base and an exponent, and then your x would be on its own, you see. So x is a 2. What we know is the graph is equal to 1 where x is a 2. So because we have a picture of the graph, we can actually use that to help us. So what I'm saying is we know that where the x value is a 2, right? Where the x value is a 2, we know that this is where, as we saw, this is where the y value is a positive 1. That's what we have gathered, you know, where x is a 2, the y value is a 1. So they asked us, where is the graph above positive 1? You see, it's above positive 1 here. You see, going onwards to wherever, to infinity. That's where it's above 1. So it's above 1 starting from where x is bigger than a 2. You see, so here you can say x is bigger than 2. You see, so that's how you can go about this question, you know. So the thing now is, I mean, like one way or the other, what do we know? What do we know? What do we know? What do we know? Yeah, let me actually just, yeah, well, I was just using this to explain, but it doesn't really change much. Let's see, what's the next question? 3 marks. If g of x is this, calculate the value of x for which they are equal to each other. G of x is what? 2 to the power of x. This is equal to this is h of x, 2 to the power of x, and then g of x is like 100 dot 3 to the power of x. How many marks are they offering? They're offering 3 marks, so they're asking where these equal. Well, I mean, without overcomplicating it, when I say without overcomplicating it, I just mean think outside the box. Like here, you can divide both sides by x to the power of 3. The reason for doing that, I mean, you can divide both sides by 3 to the power of x. Now, the reason for doing that is so that you can just, what you may call, you can just have here a fraction to the power of 1 exponent, you see. This is equal to 100. Now, guessing an x value, right, that is going to give you this. These are things get a bit tricky, obviously. Calculate the value of x for which this is equal to this. Yeah, obviously this does get a bit tricky now because this is a fraction that is what you may call, this fraction will never be a number that's equal to 100, because as the fraction is increasing, as the exponent is increasing, the denominator increases, but at a rate that is faster than the exponent. So this will never be a number bigger than 1 anyways. So dividing both sides by the square root of by 3 over x is not good. It's not a good idea. Let's maybe try dividing both sides by 2 to the power of x. I feel like we're gonna fall into the same dilemma actually, because this is gonna give you 3 over 2. You can put this to the power of x and you can make this equal to 100. This is equal to 1. And the thing is, same idea. If you divide both sides by 100, you're gonna have 1 over 100, and these will never match up. So yeah, we are in for it. I think I'm probably maybe just overthinking it a bit. So let's not overthink for a bit and just think of this as like a 3-mark question. So the thing with the 100 is 10 squared, you see. So let's see here. This is like 2 to the power of x, right? This is equal to 10 squared times 3x, 3 to the power of x. Yeah, it really doesn't seem like we are. Yeah, that question, the way it's looking, not looking very pretty. Not looking very pretty at all. So, but anyways, why was I, bro? Why am I even overthinking it? We can use a calculator, bro. We don't have to guess. Man, everything we did was fine. I'm forgetting why I was busy just being jajara. I think I was just thinking of if we didn't have a calculator. but whichever way, that's kind of awkward. Because I was also thinking of x being full numbers, you know, but x can actually be a decimal here if you just use logs, you see. Since we're working out an exponent, you see the exponent can be isolated log. The base is 2/3. The value here is 100. Let's put this in the calculator. In the calculator, we're getting here negative 11.36. Okay, yeah. So with mental math, yeah, that was not going to work. But for now, since we can use our calculator, we might as well do it, you know. And we did. So let's move on to the next question, which is question number 6. Question number 6, right? Question number 6. Yeah, let's get it. It says the graph of f of x, right? It's clearly a portion of a graph, and we're only considering x values that are bigger than 0. It is sketched below. We have point P. It lies on the graph of f, and then it says here for 2 marks. What should we do for 2 marks? For 2 marks, it says use the graph to determine the values of x for which f of x is bigger or equal to -9. So where is f of x bigger or equal to -9? Well, so this is where it's equal to, so this is where this is remember f of x represents y, so this is asking where are the y values bigger or equal to -9. So to answer that kind of a question, this is what you do. We know that it's the y value is equal to -9 here. So where is it bigger or equal to -9? It's bigger, it's equal to -9 where x is a 3, and it's bigger than -9 from 0 up until the 3. So between 0 and 3 is what we're looking for. You see, that's the portion where the y values are bigger or equal to -9. So here you're going to say x is bigger. No. X is bigger. Or yeah, let's put it this way: x is bigger or equal to 0, but then x is smaller or equal to 3. Yeah, because starting at 0 is a number that is smaller than -9. All these y values here are bigger than 0 is a number that's bigger than -9. You see, all these y values are bigger than -9, and then this one specifically is equal to -9. Moving on, 6.25. That's 4 marks, right? It says here, write down the equation of this is the inverse of f. So f looks like this, 27, right? And if you're gonna get the inverse of that, not 27x, the inverse of this, remember this represents y, right? So remember y becomes x, x becomes y. When you get inverse, like you may as well just put this so that you are communicating with your examiner. So y here becomes x, and then x becomes y. Solving for y, you can just maybe divide by a negative first, you know, and then this cancels that. So this is like -x basically. And then to get rid of the square root, you can just square both sides, you know. Squaring both sides is good because at least now we get to deal with positive values. You see, x squared. And then we have here this cancels that, right? So it's like 27 here, y. Making y the subject of the formula, divide by 27, divide by 27. Therefore, y is equal to x squared over 27. Yep, very nice. Very, very nice. You keep it moving. Keep it flowing like the water. 3 marks. Sketch the graph of the inverse in your answer book. Indicate all intercepts with the x's in one coordinate. Oh, this is the question. Did you ask us to indicate anything? Clearly show intercepts with the x's. Oh yeah. So this is an intercept with the x's. So since the original one is cutting at +1, this would be also cutting at 1. So we can just label it. Now this just reminded me of, so that's how I put that there. So since they want the inverse of f, right, the fortunate thing is you already have the original one here, so you can just use that to guide you. Because look, if the original one looks like this, all you need is your line of inverse, remember, which is this dotted line. And now that I think of it, I mean, if you're going to sketch your dotted line, you can also label it. So yeah, so that you don't lose anything for any reason. So your inverse for this graph is, you just have to remember, as we said, look at where this is. You see, trace it towards the line of inverse. And then that distance here, that should be the same distance on the other side, you see. So this distance here, the same one over there. So this is like somewhere there, right? And then you're going to have this going like that. This is what your inverse would look like, you see. So let's just take this and put it over here. And right down here. So that's what our inverse would look like. Something like this. There we go. Labeling it, we can just put this -1 there. Yeah. And then, yeah, that's going to give us 3 marks. We have we need to label one coordinate. So one of the coordinates we can label is just the inverse of this one here, where this is swapped around. So we can swap it around. We'll have -9 and +3. So what we can say here is somewhere here, right, you're going to have, wait a minute, what? Well, before that, we can also draw the line of inverse here. So if we're swapping around, I mean, like, yeah, this is not to scale very much. This is very much not to scale, but yeah, let's just maybe put something like this. This is going to be x value -9, y value 3, like that, because you just swap around the x and the y as compared to the original one in the original graph, because that's what inverse is. Everything swaps around. X values become y values become x values. So it's like 6.3. 6.4, 1 mark. Describe the transformation of f to g if g of x is equal to z. So you can see here, f of x has a negative, right? So what we know is, if remember, f of x represents y. So this is saying your y is equal to negative square root of 27x. So the thing is, with all that being said, right, if you have gone from a negative to a positive, right, it means it's a reflection about the x-axis. Because if this is what your x-axis is, you see, up here it's plus, down here it's minus, you see. So a reflection about the x-axis is what changes things from positive to negative or negative to positive, like how it is here. So here, if they're saying describe the transformation, we can just say reflection about x-axis, you see, because your y values, which is what f represents, your y values have gone from negative to positive. So that's 1 mark question. Again, these kinds of questions, it's stuff you'll be able to answer if you go through the online courses. And again, if you're going to sign up for the workshop, the in-person workshop, that you can also even attend online. The fortunate thing is, any purchase of that workshop automatically gives you access to the online courses. You see, all the online courses on our website, as long as you have signed up for one of the workshops, the one either in Bryanston, in Joburg, or the one in Pretoria, either one of the two, as long as you're signed up for them, you'll also have access to other online courses on our website. But anyways, if you have any questions, you can just ask me on IG, and then I'll definitely respond. But for now, let's move on to question number 7. Question number 7. The anticipated, much inevitable financial maths. You cannot run away from it. It's a 5 mark question. They said, at what annual percentage rate? No, at what annual interest? No, at what annual percentage interest rate your compounded quarterly should a lump sum Or should a lump sum be invested in order for it to double in 6 years? Okay, I'll read this again nicely. At what annual percentage interest rate? So we're talking about annual percentage interest rate, compounded quarterly. Should a lump sum be invested in order to double in 6 years? So this is where things get a bit interesting, right? Because here they're talking about annually, and then at the same time they are what you may call. At the same time they are talking about what's this thing, man? They're talking about compounded quarterly. So I mean, like in this case, you don't have to worry too much about it. The reason why I say you don't have to worry too much about it is because, yeah, you don't overthink it. You see, because it's the same normal everyday question. So what we know is if something is going to gain interest, it's a compound interest formula, right? So this compound interest formula here, what we know is if something is going to double, you can just make the outcome 2x, the initial investment, you can make it x. Interest rate, they said it's compounded quarterly, but we don't know what the interest is. Since it's compounded quarterly, you have to divide by 4. If it's gonna take 6 years, 6 years times the 4 gives us 24 times that the money gains interest. So you can just solve for I here. So fortunately, remember the x's, they just cancel out because divide by x here, divide by x. So with that being said, you're gonna have here x and x cancel out. So this is like a 2. And then what? X and x here. This is like 1 plus I over 4. Let's go to 24. So now let's see. If you wanna solve for I, right, you can actually just, fun enough, this is something you can actually do with your calculator. You put a 24 here, put a 24 there, you know, you'll be good. Your calculator is gonna give you, let's see here, this is gonna be very, 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 very interesting. But let's actually just put it in the calculator at once. So in this case, you will have this canceling that. This, let's just leave it the way it is, 24 with the 2 there. And then let's see what the next thing is. Here you can have 1 plus I over 4. The 1 goes to the other side, 24. Get rid of 2 minus 1 here. Let's see, minus 1 here equal to negative. Yeah, this. So if you multiply everything by 4, right? Times by 4, the whole thing here, times by 4 also. Let's see what all this gives us in the calculator. In the calculator, this is giving us 0.1172. But then the reason we do to 2 decimal places, 4, is because when you now multiply by 100, you're gonna get your 11.72%. You see, 11.72%. That's what you are going to get. So let's see what the next thing is. 7.2 says Simon buys furniture to the value of 10,000. He borrows the money on the 1st of Feb 2020 from a financial institution that charges interest at this much, compounded monthly. He agrees to pay monthly installment of 450. The agreement of the loan allows him to pay equal monthly installments from the 1st of August 2020. Okay, so if he is going to pay in August, it doesn't mean that between Feb and August there's no interest gained. Interest will still be gained. Hence why they're asking here, calculate the total amount owing to the financial institution on 1 July. Because what's going to happen is the loan is taken out in Feb, right? In March, that's 1 month later. That 1 month later, it has gained interest. March, April, May, June, July. So if you think of it, that's like 1, 2, 3, 4, 5 months later. So we need to know how much the money is worth after 5 months. So what that means is it's just a compound interest formula question, because the reason why this is a compound interest formula question, even though we're talking about a loan, is because the fact that we want to work out how much money is going to become after a certain period of time, we're always going to use the compound interest formula, because the initial money, the money we're talking about is 10,000, right? Its interest is 9% per annum, compounded monthly. So what you do is you put 9. I like to write 9. I like to write the percentages with the symbol here, and then I just put it over 12 if it's compounded monthly. Since it's, or remember, we're talking about 5 months, so n is a 5, because remember, n you only multiply by 12 if you already don't have the number of n in months already. You see, n is just months, so if you have the months already, you can just put the 5. You don't have to put 5 times 12, because it's like, it doesn't make sense. So n is 5 because it's a period of 5 months. So after that, let's see here what we're going to get here in the calculator. What are we getting here? Here we're getting 10,402.15, which is okay. So what that means is, you see, this 10,000 rand amount, or this 10,000 rand figure, it's now obsolete. You know, it has now basically expired, because he has, the loan is now worth something else specific. So what that means is, let's see here, the next questions we should use that value of, we should use that amount to help us. So let's see here, how many months will it take to repay the loan? So this is a normal P formula question. P x1 minus 1 plus I to the power of negative n, the whole thing over I. If you're gonna work out months, which is n, right? Isolating n here, you can multiply by I on both sides first. You have pi, right? X 1 and then that. So this being said, right, you're gonna say divide by x on both sides. Dividing by x on both sides is gonna be p over x. So let me actually be writing down what is happening. Times by I here, times by I. You see, so this cancels that. And then here, this is like divide by x divided by x, you see. So here you're gonna have here 1 minus 1 plus, the interest is what? No, it's just I, we're just, here I'm just like isolating n first. It makes our life easier. So you see this whole thing here, I'm gonna take it to the, so let's go to the one side here, it becomes a positive bracket. And then this whole thing here becomes a negative. Okay, so here since we work out n, as n is the exponent, so you isolate the exponent, it's gonna be equal to base. It's gonna be equal to log, the base is 1 plus I, right? And then whatever this value is what you put in here. So obviously when you multiply, when you will divide by a negative, right? If you divide by negative on both sides, you can have n is equal to, yeah, you can have negative log 1 plus I. So the reason why I do this is because when you will now just put, when you will then put, yeah, when you will then put all this into your calculator, you won't have to worry about rounding off and everything, because yeah, that's normally where people lose marks, by rounding off too early. This avoids rounding off too early. So let's see here, log 1 plus interest is 9.5% per annum compounded monthly, so you have to put that over 12. 1 minus p, we said it's, remember, as long as your amount has gained interest over some time, the original loan is now expired, or rather the original value, it doesn't mean anything anymore, because you don't owe that much anymore. You owe a bit more, which is this figure, 402.15, and this is multiplied by the interest, which is 9.5% divided by 12, right? And then this is like x. What is x? X is whoa. Are we not supposed to work out the monthly installments? Oh no, the monthly installments is 450. They're asking us how many months. We're looking at n. Whew. I was already almost shocked. I was like, no, come on. It can't be. So anyways, with all this being done, right? In our calculator, we're getting n as 25.7, well, it's 008. The reason I'm putting the 008 is because I want to say this is we're gonna have to round this off. This is approximately 26 months. You see, therefore, yeah, n is 26 months. Yeah, this is just approximate, but anyways, I mean, like, the reason why we're rounding up here is because remember your interest, it's calculated after like a full month. So if it's like 25 point something, that's just a theoretical value. But then practically speaking, a full month has to pass. So this is why we're saying n is equal to 26. The next question is out of 2, okay? What is the balance on the loan immediately after Simon has made the 25th payment? So you see, very simple, straightforward marks, because these are the kinds of questions you learn, you know, on the online courses, on the playlists, on the YouTube channel. So whichever way you learn, right? If you're gonna use the online courses, I mean, like, that's fine. If you're gonna use the online courses together with, for example, the playlists on our main channel, if you're gonna use those playlists, then you're good. Because what I'm trying to show you here is, for example, right, if you look at the playlists, right, and you go to like the financial maths playlist, you see, inside the financial maths playlist, the one thing you're definitely going to see is, for example, outstanding balance on a loan as one of the tutorials. It's literally like 2 minutes 30 seconds, outstanding balance. So getting the outstanding balance, you can just say here balance, right, is equal to a minus f. Now I know it's a 2-mark question, but meh, I always just get the balance this way. You see, I know it's a 2-mark question, but A refers to the compound interest formula, F refers to the future value annuities formula. So here, balance is going to be equal to x, 1 plus I, n minus 1, I. No, that's F, bro. I wrote F first instead of A. Scoot that over. Can I have here P, 1 plus I to the power of n. Okay. Equals to P is what? P is the value of the loan, right? 10,402.15. Interest 9.5% over 12. Time period 25 months. X is 450. 9.5%. You know, 9.5%, right, over 12. And then n is what? N is 25. Yes, minus 1. And then the whole thing here is over interest. There we go. Over 12, yeah. So this is something you just have to put in your calculator carefully. Otherwise, it's going to come back and bite you. So let's see what this gives us in the calculator. In the calculator, it's giving us 282.36, which is not bad. So this is, if you think of it logically speaking, I mean, you could be thinking to yourself, this is technically going to be his final balance of the loan, the final amount that he pays. Because, I mean, 26 months is when he pays off the full thing. So by 25 months, he's close to finishing. So that's that. Let's move on to the next question. Question 8 says the following. Determine f prime from first principles. So f prime from first principles is what we need to do, right? We need to get f prime from first principles. So the first principles formula looks like this: fx plus h ffx over h. So the whole fx plus h part, right? The x plus h part, you want to do that first. So all it means is wherever x is, you're going to put x plus h. So it's going to be 3x plus h squared plus 2x plus h. So with that being said, it's like 3, right? X squared plus 2xh plus h squared plus 2x plus 2h. This is like 3x squared plus 6xh plus 3h squared plus 2x plus 2h. Now, obviously, with everything that we're doing here, everything is fine so far. So since everything is fine so far, let's see what else. Oh, I forgot the limb part. Oopsie. And that comes after this equal to sign symbol thing. And that limb thing is important actually. So, hey, what's going on? Yo? Yeah, ne? Limb h goes to 0. So yeah, let's get f prime now. So getting f prime, you know it's equal to limb. The h of x part is just this whole thing here, right? Which is what we're gonna copy down. Let's take u. Let's copy down. Just paste you there. And then change style. Purple. There we go. Nice. Done. So yeah, looks good. So what now? Well, minus, well, f, what is this now? What is this? This is f of x, the equation of f. So since you're minusing it, it means this changes to a minus, this changes to a minus. So you're gonna have negative 3x squared, negative 2x. The whole thing is over h. Whoa. You're on a limb. The whole thing is over h. Like that. So what now? Yeah, what now for real? So this cancels this. This cancels this. And then what now? There's like 6xh plus 3h squared plus 2h over h, right? If you remove h as a common factor, you can divide both sides by h, right? Dividing by h, you're gonna have 6x plus 3h plus 2. Oh, I keep forgetting the whole limb thing. So let me not forget it. Let me not forget it. Let me put your limb. Whatever. So let's do it right. Limb h goes to 0. I didn't even put h goes to 0 here. Like, why? Why am I even? Yo? Yeah, I'm busy playing with fire here because this whole limb business, yeah, it's very sensitive. So yeah, just put your whole limb stuff there because all it's trying to do is it's what allows you to then make h equal to 0 when the time has come and you're allowed and you're going to do it without like compromising anything. So here now you can see f prime. If you throw a 0 there, it's going to be equal to 6x plus 2 because now the h goes to 0 part is gone, right? So that's how you know that a 0 was thrown where h is. Now, obviously, this is fine because if you were to use the short way of differentiating, 2 times 3 would have given you 6. Differentiating that, you'll be left with the 2 only, and the first term would have been 6x. So, yeah, this is all good. Let's move on to the next question, which is like 8.02. What is 8.2 now? 8.2 is looking interesting. Is it looking interesting? Yeah, 8.2 is looking the way it's looking for 4 marks. That's what 8.2 looks like. 8.2 says the following. Determine the what? Determine dy over dx, obviously, if this equation is what you have. So don't forget that pi is just a number. You see? Don't get fooled or don't get distracted by this situation where pi is there. It's just a coefficient. We are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions. I'll be able to see them directly. We'll be able to chat. We'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available. So before you differentiate, you wanna just simplify your expression, you see. So one way to do it is, there's a 2 here, there's a 1 there. What happens is the 2 goes under the 1, so this is what you have. Because you always want to have each term has to be in this format. You see, a coefficient, a base, and an exponent. Coefficient, base, and an exponent. So here, what you know is this is to the power of, this is a 2 with a 1 here. So you can put, what we do know is, for the sake of explaining, right, let's write it on its own here. 8 with square root of x. This, the square root of x, is just the same as x to the power of a half, because we said if there's nothing written, there's a 2 there, there's a 1 there. The 2 goes under the 1 if you want to write it like a base and an exponent. So this thing, x to the power of a half, goes upwards where 8 is. But then when you do that, the exponent here has to change to a minus. So this is what you have, 8x to the power of negative a half. So there's the minus here, 8x to the power of negative a half. This is already fine the way it is. It already has a coefficient, which is pi, already has a base, already has an exponent. So with that all being said, right, now we can differentiate dy over dx. So a half times 4 is a 2. Negative a half times negative 8 is like positive 4. Negative a half minus 1 is like negative 3 over 2. And then here differentiating 3 times pi is like 3 pi x squared. Let's see. What do we do now? What do we do? Well, we have differentiated, so we're done. Yeah, we're done. Isn't this fantastic? Yes, it definitely is. And we'll have to see it. So this is 8.2. Is it 8.2? Yes, it is 8.2. What a wow. Yeah, that's a 4-mark question. So you're gonna get marks for the simplifying part, and then you're also gonna get marks for the final answer. Because I mean, like here, here I made a mistake. It's supposed to be negative a half at the exponent there. Because if you remove 1 from the exponent, you're gonna be left with negative a half. Whew. Yeah, let's move on. The next one, it says the graph of this. Okay, that's interesting. Did I leave out anything? Is 8.2, so 8.3 is the next one. It says the graph of G is equal to whatever it is equal to, right? So the graph of G is equal to whatever it is equal to. So let's see. The graph of G is equal to this. It's this is what? It is what it is. This graph of G has a minimum value of 4. No, a minimum value at x is equal to 4. So what it means is it turns at 4 or something like that, or the lowest values are 4. For 6 marks, they say calculate the values of A and B. So when they say it has a minimum value at 4, what you need to remember is that here you have to think of calculus. Meaning, as an example, right, for some odd, just as a random example, if you have a cubic function, right, this is usually referred to as the minimum value. It's a minimum turning point, actually. This is referred to as a maximum turning point. So what you normally know is the minimum value is where the first derivative is equal to 0, provided that this is an equation of f of x. So what we know is, if we are going to be strategic about this, what we know is anytime they're speaking of a minimum value here, we should keep in mind that it is a point where the first derivative is equal to 0. So let's get the first derivative and make it equal to 0. So the reason I'm doing that is anytime you normally need to get two variables, it means you need to work those variables out simultaneously. So you need two equations. You already have one equation here. Let's get another one, which is our first derivative. Our first derivative, we're going to make it equal to 0. And we know that that first derivative is equal to 0, specifically where x is a 4. So or before we even get our first derivative, we just need to at least simplify this equation in a way that is manageable. Ax squared. So here the x can go on top. And here we are, equal to 96. So all this being done, what do we know? What do we know? What do we know? Okay, we do know that, yeah, if we're going to differentiate this, right, let's differentiate. You're going to have here 2 times a, which is like 2ax. Negative 1 times b is like negative bx. Negative 1 minus 1 is like negative 2. Whoa. What's going on here? Oops. That part was not necessary. Because what matters is that this is the equation of the graph. The equal to negative 96, it just forms part of the description for now. But we have the equation of the graph here. We differentiated it. We know that if you make it equal to 0, the first derivative has a minimum where x is a 4. So what we know is the first derivative equal to 0 is happening where x is a 4. So if you make this a 0, it's specifically where x is a 4. So doing this, you have an equation that has a and b only. Having an equation that has a and b only is useful because, I mean, you know, it's just helping us. When I say it is just helping us, I just mean that we have to be careful. So this is like, why am I putting a negative plus here? It's a negative. So this is going to be minus b, and this represents 1/16. So this is like this. This is a 0. If you want, we might as well even, yeah, this is fine. This we can lay. This is one of our equations. Your other equation, right? You have to be careful. Your other equation is the original one, but the fortunate thing is this is your x value, and this is your y value, because it has a minimum value at 96 where x is a 4. So where y is, you put 96. Where x is, you put a 4. So here you're gonna put 96, and then a, x is a 4, b is a 4, and then let's see here. For now, it's like 4 squared is 16 plus b over 4. This is equal to 96. No. I forgot my a. So what now? Yeah, we just need to carry on now, because Let's just maybe isolate a in this equation. So you have b over 16, right? There's 8a. If you divide by 8 on both sides, you're gonna have b over a big number, something like that. Yeah, it's gonna be a big-ish number. So it's like, yeah, what do we do now? It's like what? 160 minus 32. That's like 128. Yeah, that's like gambling there. I don't even know why we are not using the calculator, bro. Come on now. 16 times 8, But it's fine, that's correct. So here, this is what we know a is. So we can now put it in this equation, right? 1 over 28. No, b over 128. And then we have here b over 4. This got 96. So this is like 16 over 128. So 16 divided by 128, we know that that's just, what? Your way. I think it goes in like 8 times. Yeah, I think it goes in like 8 times. So this is like b over 8. And then b over 4. 96. So here clearly there's a 4 and an 8 and a 1. So the LCD here is just 8. So this has to be times 2 over 2, right? And then here times 8 over 8. So 96 times 8 is going to be like 768. What a wow. And then this is b plus 2b over 8. This is over 8 also. So since they're all over 8, we can just multiply by 8 on one side, multiply by 8 on one side, the 8's go away. Now you have this here equal to b plus 2b is like 3b. So this number here divided by 3, yeah, these numbers are quite big, but yeah, let's not be alarmed because I mean, like we did talk about, they did say the minimum value is like 96 and something. So if this is the numbers we're getting, then we might as well just keep them, because I mean, they're the numbers we're getting, what can we do? It's the numbers we're getting, but they do seem a bit too, do they seem a bit too big? No, they look fine. They seem fine. They seem fine. This seem fine. So it's fine. Let's just carry on. This is 256. So with 256, that's the value of B. The value of A, let's see what is the value of A. The value of A, you'd have here 256 over 128. This is equal to A. Your value of A is a 2. So that's that. And that is the way we like it. Getting 6 marks there. Nice, easy 6 marks. Let's move on to the next question. Okay, question number 9. Question number 9. It says, the graph of h, right? This is clearly a cubic function. The graph of h of x is equal to this equation. It is sketched below. It's a cubic function. So this cubic function being sketched below, they said a and b are the turning points. Yes, there's a over here, b over there. So the thing is, anytime a graph turns where there's an x-intercept, that has certain implications when you will be talking about the equation of the graph. That has certain implications that we should not forget. So carrying on, let's see what we have to do. So from here, with everything that we're doing now, right, we have to be careful. So it says here, T, it's a point here somewhere. And then it says the graph of h passes through the origin. This is also good because the origin is also one of the x-intercepts. So this question looks very nice, to be honest. 9.1 says we get a and b. So a and b, if you show it the equal to these values, that shouldn't be too difficult because there's a lot of information here that we can use to our advantage. So c is just the y-intercept, right? So c is the y-intercept, which is just a 0. So that's not even supposed to be there because it's just a 0 anyways. Or rather, it's fine, it's a 0. So getting A and B, we can work it out simultaneously since it's like two variables. This is an equation of H. Yeah, so we can say H of X, its equation. Well, it starts by going down. So yeah, negative X cubed, and then minus AX squared, and then plus BX, right? Plus C. So the thing is, what we do know is the following. We're trying to get A and B. Normally, if you're going to get two variables, you may want to get them by working it out simultaneously. So the one thing to do is, I mean, like here we only have an X value. We don't have the Y value. So that's not very promising. So this is where this kind of information comes into play. As long as your graph has a turning point where it also has an x-intercept, what that means is that if you have, if you factorize this equation, right, what you want to remember is your equation factorized will always be equal to a variable here, x minus 1, x minus 1 again, and then x minus 2. I mean, x minus a certain x-intercept, x minus another x-intercept. These will be the same value, and then this will be a third one. Anytime you factorize a cubic function, it will be in this format. Now, the thing is, this value of k here will always be the coefficient of x cubed. So k here is negative 1 by default. So we have k. We don't have any of these, right? But we at least have this second one. It's a 0. And a coordinate that the graph passes through, we don't have. So wait, we do. They told us b is 6 and 0. Whoa, okay, that's good news. So it means we have this here. This number here is a positive 6. You see? That's information we know based on knowledge that you should have. And this kind of knowledge, you definitely are able to get it from our online courses. The link to that is in the description, you see, because on our website, the online courses, they're basically structured in such a way that allows you to like learn your entire syllabus in one place. You see, you're able to learn the entire syllabus in one place. There's a specific course for each individual subject. For example, but before I dive into the online courses, I mean, we do have a workshop coming up, right? If you're watching this before the 19th and the 18th of October, or technically 2022. So there's a Bryanston workshop in person, and then there's a Pretoria North workshop in person. You can join the proceedings online on the 18th and the 19th. That's for the 399 here, because if you check here, right, there are two options to attend. The first option is in person. That's like 999. The second option is online, which is like 399. That's on the 18th and the 19th in Bryanston. And then if you live in Pretoria, that's on the 20th and the 21st. Fortunately, if you do sign up for the workshop, you do get access to the online courses already. So you can go through all that. But if you just want access to the online courses, they're currently on sale actually, but it's really like ending tomorrow. But anyways, yeah, you have access to the entire syllabus. You see, so in the entire syllabus, so going through the entire syllabus, you do go through questions where you see these functions and graphs and calculus there. Those kinds of courses is where you will be learning things like what I'm just mentioning over here. You see, very important stuff. So that now let's see what you can do. Yeah, we seem to have quite a bit of information. The only thing is here we have an x, we only have an x value and the y value is blank. So let's see how far we can go if we do that. The y value is y, k is negative 1, this is like a 6, and then 6 again. The other one we know it's a 0, so x minus 0 is just 0. Now the fortunate thing is, remember, we know what the x value is, it's a 3, so 3 is there, and then 3 is here, 3 is here. Because remember, here you'll be putting an x value, and then here you'll be putting a y value. So they just said y is y, and then x is 3, based on this coordinate here. See? So say 3 minus 6 is negative 3. and then you're going to get another -3 here, and then a 3 there. So this is going to be a plus. Negative and a negative is a plus, times a negative, it's a negative. So this is like -27. That's what y is. We've just worked out a value of y for this. So the reason why this is important is because we can now throw in, what can we now throw in? Well, funny enough, what we just did right now was not necessary, because we didn't even have to put the 3. Yeah, that was actually just overkill. Let's actually leave the 3 out, because yeah, here we're just trying to get the equation of the graph. So this we'll probably even need to do it for one of the questions here, which is calculate the coordinates of A. Where is A? Well, never mind. Let's just delete this for now. We'll probably need to do it later, but for now, we don't need to get any coordinates in this equation. We just need to get the equation. Now, getting the equation, we can just carry on from here, you see. So let's just be careful here. -1, x times x is x squared, this times this, and then let's see, this and that is this times this is -6, then another -6. So you have -12x, this and this, positive 36. Okay, so the x, we can just write this one in front here, you see, together with the negative. So this is like -x. So this is like -x cubed plus 12x squared minus 36. This is y. So with that being said, right, yeah, we just need to be careful. So now we can see, therefore, b is equal to 12. I mean, a is equal to 12. We can see it clearly. And then b is equal to -36. As you can see, this is a, this is b, which is what we can see from the beginning here, a and b. Now you see, this is where your knowledge gives you your marks out of the 3. So that's that for this 3-mark question. 9.2 says we should get a coordinate of a for 3 marks. A is one of the turning points, right? And your basic knowledge will tell you that to get a turning point, you need to make the first derivative equal to 0. So let's see, y here, right? Y, the first derivative is dy over dx. So differentiating this equation, right? Let's see, copy and then paste. So here we have the -3x squared, positive 24x, right? Positive 24x, and then this just falls away. So first derivative equal to 0 is what gives us the turning point. So solving for x here, we can just take out x as a common factor. We have, no, we can take out 3x as a common factor, actually. 3x as a common factor. We have here -x plus 8. So here we have 3x equal to 0. And then what? X is equal to 0. The other one, -x plus 8 equal to 0. X is equal to 8. Okay. So what do we do now? Yeah, well, this does not make any sense because 8 is not one of our answers. Maybe it's because I made a mistake. 3 times, what did I do wrong? 3 times, yeah, because one of our other turning points should be a 6 there, because they said b is what? Our value of b was what you may call, was what we have just there. So let me just see here. Oh, I forgot the 36. Oh, I forgot the 36 has an x. Oh, let me see here. 36 multiplied, and then multiplied. Oh yeah, this has an x. Yeah. So even though that was, well, it didn't affect the previous question because, but then here it definitely mattered that we put the x here. So if x is there, it means this would be a 36 here. This would be a 36 here. Meaning, yeah, this has to go away. So you see, you don't just get answers, you have to fact check it. But fortunately, we know one of the x turning points has to be a 6. So yeah. So here you can actually take out a -3 if you want. You have x squared here, negative 8, and then +8, +6, right? So divide both sides by 3, by -3 rather. You're going to have x squared minus 8x plus 6 equal to 0. So in this situation, this don't make any sense again, bro. Like, I feel like I'm just making dumb mistakes. Why am I making dumb mistakes? I don't even know. Yeah, it's kind of annoying. It really is. But what do I even mean by it's kind of... No. Dude, 36, bro. Come on. 3 times what gives you 36? Is it 9? No, not 9. 8? No. 6? No. Sure. Why am I blending out now? I'm like proper blending out. Whew. I mean, just calm down. Third, you know what? 12. What is 12? Whew, that was dumb. Okay, yeah, so this is 12. So now factors of 12 that give an 8. It's basically 6 and 2. Yeah. So a -8 would be negative and a negative here. Yeah. So here x is 6 or x is 2. Yeah, that definitely makes sense, you see, because one of them has to be a 6, the other one obviously has to be lower than 6. So this is all good. Aries, all good. Aries, all good. We can carry on from here. So what we know is, therefore, wait, we have to carry on. We only got the x value now. To get the y value, we have to throw in the original equation. You see, y is equal to, wherever x is, we're going to put, what is this thing here? Copy. By the rivers of Babylon. Let's see here. Let's copy, paste. So this is like negative what? 2 cubed plus 12 with a 2 here squared minus 36. That's that, yeah. So here 2 cubed is like 8, right? 2 squared is like 4. 4 plus 12 is like 48. And then 36 times is like -72. Now obviously this is like 40, right? 40 minus 72. What? This number seems a bit too big, eh? Well, it does seem a bit too, no, too small, but it's fine. Because I mean, like, these are numbers that are all accurate. So here, therefore, a is going to be, the x value is a 2, the y value is a -32. That looks absolutely fine. They want us to get the value of y. So we already know what to do to get the value of y. We just throw everything into we have the equation of the graph anyway. So x is a 3. So in the equation of our graph, we're going to put x as a 3 here. You see, so y is equal to negative. Well, here we have to be careful, you see, because the negative is out, then 3 here. So here, 12, 3 squared, -36, 3. It's a 1-mark question, so you really don't have to stress too much about this. Put everything in the calculator and then let's just give them what they want there. So just, yeah, nothing crazy. Moving on, 9.4 says, is the graph of h concave up or down at point t? Point t, well, it looks like it is concave down. The reason why it is concave down at t is because, you see, the one x value here is at 2, the other one is at 6. In between 2 and 6 is 4, because in between your two x values of your turning points, that's where the point of inflection is. And the point of inflection is where your concavity gets split up. You see, one side that's smiling here is concave up. One side that's frowning here is concave down. So t is on the side that's concave down. So let's see how many marks they're offering. just 3, right? So let's say here concaved down. So the reason for that is, let's get the point of inflection, or the x value of the point of inflection. So getting the x value of the point of inflection, we have to differentiate twice. So differentiating once is going to be negative 3x squared plus 12x minus 36. When you differentiate again, this is how you write it out. Is it? Well, for you not to get caught in the mud of all this, what? This is written as h of x, right? So let's just make our life easier and just refer to this as h of x, you see? So that when you're differentiating once, twice, it's easier to see. Ship, yeah. So here it's like negative 6x plus 12. What? Bro, why am I even rushing, bruh? It's supposed to be 24 here. Come on, dog. Come on, bro. Come on. Come on, doggo. 24. So now you can see if we differentiate this and make it equal to 0. I should have just used the x, the midpoint of the x-intercept. But anyways, here we are already, so the same. Uh-oh. This is definitely wrong. Yeah. No, it's not wrong. The 4 is what we're getting. So here we can say t value of, oh no. What? I feel like I just bugged it up real good. It's concaved up because 4 is like after the 3. This is not to scale. Yo. Yeah, this is very bad, eh? Don't judge a book by its cover because it's concaved up. Wait, what? Dude, don't blow the moment for me now. Yeah, it is concaved up. Yo, what a wow, ne? What a wow. Because, yeah, it is concaved up. The sketch doesn't look like it, but the calculation tells us it's concaved up, you see. Let's see here. Value of t is where x is equal to 3 and the point of inflection and the point of inflection is at 4. So t is, you know what? No, this explanation is too long. So let's just get something straightforward and simple. You see, so we said x here is a 4, right? That's where the concavity changes. So let's state that concavity changes where x is equal to 4. The x value of t is 3, so t is concaved up because the x value is before the 4. You see, because before the 4, the graph is still doing its smiling thing there. So yeah, this is more or less just not to scale, but it is what it is. So here we say it is concave up. So just be careful with these kinds of questions. It says determine the coordinates of the point of inflection. Well, based on our previous question, we said the x value is a 4. So the y value, we can just get that by throwing it into our equation, you see. Y is equal to negative 4 here. The 4 there here. Negative 36 here with the 4 there. So now what? What do I need? What do we need? We need hey, we need the calculator, my guy. That is what we need. We need the calculator. So the calculator, what is the calculator giving us? You know, where's my calculator? Let me see. Negative that, negative this, 12, this is gonna give us a negative 16. So here, therefore, 4-coordinate negative 16 is your answer. So let's move on to the next question. So 10.2 says here that we should calculate the maximum daily income per room. So when you think of the words maximum or anything like that, you should just automatically think of differentiating and making your equation equal to 0. You see? So in this case, before you differentiate, you have to make sure that you put everything in order. So this is going to give you, this is going to just look at everything is actually in order. Actually, I don't even know I'm saying what I was saying, but I think to make it a bit more clearer, this is what we have, right? So when you differentiate, you can just say this is in terms of x, right? So this is going to be 82. This times that is going to be 1/25x. So if you're going to make this equal to 0, because you're not differentiating the equate to 0, right? This is like 82. Yeah, I think x is better if you write it as a numerator, because now you can take it to the left. You're going to have like positive x/25, right, equal to 85. Now, if you multiply by 25 on both sides, times 25 times 25. Let's see here. Yeah, it's going to be a big number, you see. X is going to be equal to what now? Is this 82? Why am I writing 85 now? It's supposed to be 82. Yeah, 82 times 25. That seems like it's going to be quite a big number. No, not quite a big number. It's just, it is what it is. This is 2050. These are just a 2-mark question. So as compared to the previous one, this is not so bad. But yeah, let's move on to question number 11. Question number 11. Question number 11 says, events A and B are mutually exclusive. So before we even carry on, as long as events are mutually exclusive, it means the probability of A and B is equal to 0. There we go. That's the probability of A and B. So it says here, for 3 marks, right, the probability of A is equal to 2 times PA. No, the probability for 2 marks, it says the probability of B is equal to 2 times the probability of A. Okay, the probability A or B is equal to 0.57. Oh well, calculate B. So yeah, that's quite interesting. We need to calculate B. So calculating B, well, if they're mutually exclusive, it means that, well, whichever way, the rule of probability or the addition rule of probability says the probability of A or B, right, is equal to the probability of A plus the probability of B minus the probability of A and B. So let me just write that down here. See, minus, let me finish this thing here, minus the probability of A and B. This is the addition rule of probability. So it doesn't necessarily matter if it's independent events or dependent events. This is like a law of probability. So we have the probability of A or B, right, is 0.57. The probability of A, well, if you look at it nicely, here you can divide by 2 on both sides. So you'll have here probability of B over 2. That's what probability of A is. So where we see this here, we can just put half the probability of B, you see? And then here, plus the probability of B, and then probability of A and B. Well, since they're mutually exclusive, this is a 0. This is where your knowledge comes into play, you see? So a half plus 1, that's like 3 over 2. You can just get that from your calculator. And then here, 3 over 2, you can just divide that on both sides, right? So let's see here. Divided by 3 over 2, divided by 3 over 2. What are we going to have here? This cancels this. This is like, there we go. 0.4, 0. What? 0.57 divided by 3 over 2, right? What do we get here? So in this situation, I mean, you know, what do we get? 0.57 0.57, right? Yeah, it's 0.5, no, 0.57, 0.57 divided by that, that's going to give us 0.38, which is perfect. Now, let's see, 1.2, right, says the following. A box of 40 calculations. Okay, calculators. A box of 40 calculators is sent to a store by a supplier. Then it says the owner of the store is not aware that 5 of the calculators are defective. Okay, 2 calculators are selected at random from the box. The first one is not being replaced before the second one is selected. And then it says here, the first one is not being replaced before the second one is selected. So it means they take out the first one, and then whatever is left, they take out a second one from there. And then they say, what is the probability that the first calculator chosen is not defective? So not defective. Firstly, you want to ask yourself, how many not defective calculators are there? It's 35 calculators that are not defective, because they said 5 of them are defective. So the ones that are not defective is 35. So the probability of getting a calculator that is not defective, it's going to be 35 out of the total, which is 40. So you can simplify this. The highest value that can go into both of them is like 5. So 7/8 is your answer. So let's move on here to the next question and put an 8 here. What just happened here? Did I? Oh, 7/8 is your answer. The next one says, what is the probability that if 2 calculators are selected, one calculator is defective and the other one is not? So this is a tree diagram scenario, you know. So when you choose a calculator for the first time, let's say here defective, not defective. When you choose a calculator the first time, chances of choosing a defective one is 5 out of 40. Not defective, 35 out of 40. Fine. When you'll be choosing a calculator again, also still 2 options. You see? Total calculators is now 39. So total calculators is now 39, fine. But then one defective calculator has been chosen, right? So it means only 4 are left. Here, all the non-defective calculators are still there. Here, if a non-defective calculator is chosen, it means all the defective ones are still there. Here, one non-defective has been chosen, so only 34 are left. So here, says what is the probability that if 2 calculators are selected, one is defective and the other is not? So to get the probability of that happening, we have to think of these outcomes. You see, this is like D and D, this is N and D, this is D and N, this is N and N. So keeping that in mind, we have here, this is going to be this times the previous one, this times the previous one, this times the previous one, this times the previous one. So we want a scenario where it's one defective and one non-defective. So it means this or this. So those 2 outcomes, it's going to be this multiplied by the previous one, right? So let's see here. Let's see what this probability is. And then for this one, it's going to be this multiplied by the previous one. So these 2 probabilities here are what we need to add up for us to find our answer. You see? So yeah, that's what we need to keep in mind when we're doing things like this. You see, it's not crazy, it's not anything out of our reach. So here you're gonna just have your value here, whatever it is, you wanna add it to this second value over here. You see, copy, paste. So the idea now is, if you're going to, since you've done these 2, this plus this in your calculator, 35 over 156. This is fine. I mean, it's the simplest form. The next question, right, that we need to answer says the following. 11.2.3, right? 11.2.3 says, what is the probability that if two calculators are selected, both are defective? Well, that's like D and D. So that's like 4 over 39 multiplied by 5 over 40. So it's like 5 over 40, right? Multiplied by 4 over 39. So this in your calculator, this is going to give you 20 over 1,560. Let's keep moving forward. This next one says 4 different economics books and 3 different life sciences. So it's 4 economics, 3 life sciences. Okay, 4 economics books and 3 different life science books are required to be placed on a shelf. Okay, so it's 4 economics, 3 life sciences. Okay, and then it says if you decide to place any book in any position, in how many different ways can they be arranged on a shelf? Well, it's 4 objects plus 3 objects, so they can be arranged in 7 factorial ways, since there are no restrictions. 11.3.2 says if 2 particular books must be placed next to each other, in how many different ways can they be arranged? So in that case, you have 7 positions, right? 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So if 2 are stuck together, what you do is these 2 that are stuck, they can be arranged in 2 factorial ways. And you want to look at them as like one object. So you're going to say one object, 2, 3, 4, 5, 6 objects. These 6 objects can be arranged in 6 factorial ways. So your answer is going to be 6 factorial times 2 factorial. And in that kind of a situation, let's see what we are getting here. This is giving us 1,440. The previous answer in the calculator, let's see, it's giving us 5,040. But it's a 1 mark question, so 7 factorial is good enough. 11.3.3 says if all the economics books must be placed next to each other and all the life science books must be placed next to each other, in how many different ways can they be arranged on the shelf? This is also easy. 1, 2, 3, 4, 5, 6, 7 books. So the idea is the economics have to be together, right? So you look at them as one object. The life sciences have to be together, so you look at them as one object also. And then what you do is the 4 objects can be sorted in 4 factorial ways. The 3 can be sorted in 3 factorial ways. And then the 2 groups, 1, 2, can be sorted in 2 factorial ways. So these are the total number of arrangements. You see? So that in your calculator, that's what it gives you. 288. There we go. That's the way we like it. Nothing crazy, nothing major. We are all good. We are all happy. So that's that for this paper. If you obviously had questions that you still have questions on, well, the one thing I recommend is the online courses, because the online courses is definitely what you need for you to be able to get a much broader understanding of these kinds of questions. But obviously, depending on when you're watching this, right, we do have a workshop coming up at 22 on Sloan. This is in Johannesburg. This is, let's say, if you're going to be in Johannesburg, then you can attend at the Johannesburg branch. These are the details to the workshop. It's in person. However, if you want to follow along online, you can also do that. The in-person price is 999. That's for Joburg, but then Pretoria is also the same idea, but on different days. these are the details for the Pretoria workshop, and as mentioned, it's also 999, and then the online proceedings you can follow along during the Johannesburg workshop, which is on the 18th and the 19th. And then remember, anytime if you do sign up for the workshop, you also do get access to the online courses, all of them, until the end of the year. Meaning by the time you do attend the workshop, you'll be able to ask very detailed questions. From my side, don't forget to subscribe. Don't forget to plug your friends also, because all this is super, super useful. But anyways, from my side, I'll catch you in the next video. We are hosting an in-person math grade 12 workshop. So the idea is there's going to be 2 workshops, one in Bryanston and one in Pretoria North. The one in Bryanston is going to take place on the 18th of October until the 19th of October. The one in Pretoria North is going to take place on the 20th of October until the 21st of October. If you want to follow the proceedings online via Zoom, that will only cost you $3.99. The full details for that are linked in the description below. The main idea with the workshop is you will be able to ask very detailed questions with regarding anything metric related, actually. Applying for university, upgrading, taking a gap year, math questions, very specific, very detailed math questions. And the good news is, as long as you sign up for the workshop, you will also have access to the full online courses, meaning prior to the workshop, you will be able to go through the online courses so that on the day of the workshop, you are able to ask very detailed questions. So if you do opt to join in online, that will be from the 18th to the 19th, meaning you will be following along the proceedings that will be taking place at the Bryanston branch. The good news is, if you do sign up for the Pretoria in-person workshop on the 18th and the 19th of October, you will also be able to follow the Bryanston proceedings online via Zoom, meaning you'll be able to ask questions. I'll be able to see them directly. We'll be able to chat. We'll be able to gel. It is one of those things you definitely do not want to miss. Seats are super limited, so you can hop onto our website and check if there's still space available.